QSO Today, episode 233, Ray Waldemar WA6NVL. This episode of QSO Today is sponsored by Ikon America, makers of the finest HF, VHF, and UHF transceivers for every level of amateur radio operator. Visit Ikon at www.ikonamerica.com/amateur to find out more about Ikon's exciting line of products. And by QRP Labs, makers of the QCX single-board transceiver kit and a host of other QRP radio kits and parts for the ham radio builder. Click on the link to QRP Labs in this week's show notes page. Please support the QSO Today podcast by supporting these fine sponsors. Welcome to the QSO Today podcast. I'm Eric Guth Z1UG, your host. I visited the Pacificon conference last October in the San Francisco Bay Area of Northern California. Many of you know that I hail from Southern California many years ago, and at that time, Northern California, to me, seemed like an entirely different state. This may still be true today. At Pacificon, I got a chance to meet up with listeners, many old friends, and I made some new ones. Some of these new and old friends you will hear in future episodes of the QSO Today podcast. When I was in the room on Friday night at the Pacificon conference where my friend Wayne Burdick, N6KR, was telling the story of his early QRP rigs, I looked around the room to see if there was anyone who might have known Wayne as long as I did. Sure enough, there was my guest today, Ray Waldemar WA6NVL. Ray and Wayne had known each other since junior high school in La Mesa, California. I first met Ray in 1972 at the El Cajon Amateur Radio Club. I moved away in 1973 and hadn't seen Ray since, so it was a thrill for me to see Ray again after 45 years. He looks just the same, just a little older. And while Ray and I did not get much time at Pacificon to catch up, he agreed to come on the QSO Today podcast so that you and I could catch up with Ray after all these years. WA6NVL, this is Eric, 4Z1UG. Are you there, Ray?
Good evening, Eric. 4Z1UG. This is WA6 November Victor Lima.
Ray, thanks for joining me on the QSO Today podcast. I have to say that it was a real thrill to meet you again after 45 years. You still look the same. However, before we get to catching up, the listeners of the QSO Today podcast want us to start at the beginning of your ham radio story. When and how did it start for you?
Well, it started for me in junior high school when my English teacher, Dick Leffler, WA6COE, put together an amateur radio station at our junior high school, and our physics teacher, Roger Miller, was also an amateur, and we had some receivers that they got for us to start off doing shortwave listening until we could learn the Morse code to become novice operators.
And where was this junior high school?
This was Parkway Junior High School in La Mesa, California.
So how did it go from there?
It went very well. My dad was into engineering also, so he would bring me home components and stuff from work and set me up with a soldering station. And I built a lot of little things. And as I was able to earn some money through mowing lawns and stuff like that, I got my amateur radio license. I think I was 15 years old at that time in 1970. And in La Mesa, where we lived, there was a Heathkit store. I had a friend that lived down the street from me, which you've interviewed also, Wayne Burdick. His call then was WA6HQH. And he and I would go over to the Heathkit store and sit around and talk to the technicians and stuff. And they had a full line of amateur radio equipment. And as I saved up some money, allowance and things, and mowing lawns and washing cars and things like that, I went and purchased myself a receiver so that I could do some shortwave listening also. And so in the beginning, I did a lot of shortwave listening, and that's when I found out about QSL cards. And so I was sending off letters to all over the world and getting responses back from, Radio Moscow, Radio South Africa, Australia. And I said, wow, this is pretty neat. I can hear all over the world. Like I said, our junior high school teacher, he said, well, hey, how would you like to talk to some of those people all over the world? And I was just totally amazed, like, I can talk to the same people I'm hearing, these broadcast stations. And they said, yeah, I can show you how to do that. And so one time in class, in our physics class, we all built code oscillators, Morse code oscillators that our physics teacher got all the components for all of us to build. And so we all sort of learned Morse code that way.
Now, you got your license, you say, at age 15 in 1970. Was that your novice license?
Yes, I was WN6NVL at that time.
Very unusually, you've kept your call sign throughout all the years.
Yes, I've looked at the vanity calls and stuff, and mine was always easy to send Morse code with when I was doing it, so I had just kept it.
Now, the listeners know by this point that you and I met each other in 1972 at the El Cajon Amateur Radio Club. How was your amateur radio club experience? Mine was terrific, but maybe you had a different take on it?
It was a lot of fun. I then got to meet a lot of older gentlemen who had lots of knowledge, and one of the folks that I had met there, Harley Gabrielson, his call was K6DS. He was one of my mentors. He's also the same gentleman who designed the CW code oscillator for the AMSAT Oscar 1 satellite. So for the very first amateur satellite that went up, he designed that oscillator. And he became one of my mentors also and helped me design some RTTY receiver equipment.
Well, I think one of the unusual things to think about San Diego, at least in those days, was it had a very strong post-war military feel to it. There were a lot of engineers in the ham radio club who had a lot of experience and parts.
Yes, there was also a lot of folks that were involved with MARS, the Military Amateur Radio Service. And so a lot of those guys had parts, surplus parts and stuff like that. And there was quite a few surplus shops that had military equipment. Wayne and I also used to modify a lot of what they called ARC-5 receivers and transmitters. Was our first 40-meter transmitter and receiver. And that was a lot of fun modifying military equipment.
Yeah, that's really cool. I remember those. Did you ever have the K6QXN coils for your tri-band inverted V?
No, I had another gentleman who wound them on a lathe with the red enamel wire.
Right.
And yes, we had made traps, coils that way, I should say, the coils, yes, for the multi-band antennas. My first 15-meter beam that I made, two-element beam, was made out of just regular conduit, house conduit, to where you could make a coil and just take some 2x4s, and I took 4 pieces of that EMT stuff that they had there for house conduit or building conduit there, and made a beam.
Which is steel conduit at the time. Probably still
That
is.
is correct.
Yeah,
yeah,
it wasn't aluminum. It was actually kind of heavy.
Yes, it was. And but it was fun to look at how I built it on 2x4s and put it up on my little crank-up tower that I was able to get surplus.
So do you have a rig that you consider was your very first rig?
My very first HF rig was probably my Heathkit transceiver. I had an SB, and I had the transceiver at first, and then I got the individual transmitter and receiver. I think they were the 401 and the 303. But my very first one I built was the actual transceiver.
So that's like the SB 101?
Correct. Uh-huh.
How about
or
that?
Or 102, something like that, yeah.
Yeah, that was very cool. Remember your first contact?
Very first contact, I still got his QSL card. It was like a K6OI, something like that. And I later had seen that call sign at one of the conventions I went to, and it was a reissued call sign by then.
And what was that like? Do you remember it?
Well, the very first calls that I put out there, I actually found out that my power supply had some issues because I got a phone call from a neighbor, amateur radio operator, Dave Osborne, who was he was in La Mesa too. He said, son, your radio's got key clicks. It's got chirps. It's all over the place there. He goes, your fifth sounds good, but your radio sounds bad.
Did he come and help you?
Well, he had me come over to his garage, and we took a look at the power supply, and we found out that the capacitors were indeed defective. He says, you need to get some new big electrolytic capacitors, or actually I think they were oil-filled capacitors at that time. And he goes, these need to be replaced because they're not filtering your high voltage power there, and we can definitely hear it. So he did end up repairing it, but showing me everything that needed to be done.
Did amateur radio play a part in the choices that you made for your education and career?
Oh, definitely. Well, and that my dad was a Navy chief, like you said, San Diego. He was a fire control technician there for radar systems. So I learned about radar, how that worked at a very early age from my dad. But and which is funny because when I ended up moving up to Los Angeles, I went to work for a company called Hughes Aircraft Company. Yes, the one that Howard Hughes had started. The facility I was at made airborne radar. And so when they were doing my interviewing process, they said, wow, for a young person, you sure know a lot about radar. Did they teach you that in college? I said, no, my dad did.
Do you have a current rig that's a HF rig?
I have several. And mainly because I still like some of my older ICOM stuff. ICOM was always my favorite for HF type, and but now I use Flex Radio because software-defined radio seems to be the future now. I like how you can take a radio and have the basic characteristics of a transmitter and receiver, but put just about any kind of modulation you'd like through it, either analog or digital.
Which Flex radio do you have?
I have a Flex 5000 and a Flex 6700.
Do you operate those remotely?
Yes, I do.
Do you have it out in some rural area away from the noise and the CCNRs?
Well, it's actually located at a home in San Diego, and it is in a very quiet neighborhood. I don't have a whole lot of electromagnetic noise in the neighborhood to deal with, which is really nice. I have an S floor of about a S4 there, S3 to S4. And most of the noise that I'm getting is from people that have now gone and put solar panels. The big fad here in Southern California, a lot of those inverters that they use that convert that DC energy into AC for the homes do generate a lot of noise.
Right. There's a great article in QST last year where a guy took one of those panels apart and created a way to build a wiring harness that would eliminate the noise so that it would be compatible with ham radio. I'll put a link to that in the show notes. Are you able to work with the neighbors in terms of reducing the noise level, or is it just enough that you can still operate just fine?
Well, I now know the signature of the spectrum that these generators put out, these inverters, and most of it, they're on a couple hundred kilohertz spacing, the switching noise that they use, or they generate, I should say, and 7.2 megahertz just happens to be one of the spots that falls right on one of the neighbors here. But what's nice is that at night, it's not working. So when I'm on 40 meters at night, I don't have an interference problem, only during the day.
What's your favorite operating mode?
Well, currently, it's been FT8. That's been a whole lot of fun because I'm so impressed what Joe Taylor has done by able to take a very low power signal and with coherent timing, able to, for 5 watts, go all over the world. I'm very impressed with that design.
Now, isn't there a new version of FT8 that's kind of more interactive, more QSO oriented rather than just exchanging call sign and QTH?
There are some new ones that they've been coming up with. I haven't played with those yet. I'm still new at this whole digital stuff in that aspect on HF. I'm just impressed at knowing what propagation information. That's why I really like to listen to a lot of the shortwave broadcasts, is because I get an idea of how good the bands were, and stuff that I did with the military design. We would always be using other signals to see what propagation was as to what frequency we would choose.
Do you think that FT8 has kind of maybe changed the way you think about the Sunspot Cycle and how propagation works?
Well, yes. That and using Whisper, like you had mentioned earlier, to be able to look at the different stations at any time of the day and being able to look at what propagation from different transmitters and the different receiving points on the planet is very impressive. I know the government has spent a whole lot of money being able to have transceivers that will go and search out and find what is the best frequency to be operating on, and to see this amateur stuff, what we've done, and to be able to pick a frequency and band based on propagation is very neat, very impressive.
Well, it seems to me that that's almost a flex radio accessory in the near future, and that is to take the information off of the Whisper site to set up your radio so that you're ready to operate on the MUF of your of the current moment.
Well, I agree. I mean, the technology that's out there now, it is so, to have a frequency agile, a power agile radio, because, in amateur radio, the FCC does ask us to try to use the minimum bandwidth, minimum operating power, things like that. And now to be able to have radios that it can actually see below the noise floor is very impressive. I mean, that's, having time synchronization. I know a lot of the guys that are going to listen to this podcast are going to go, wow, they thought that if you can't hear it, it can't be heard. And now I'm seeing signals that are below the noise floor, kind of almost like with GPS, how it works, coherent signals. It's very impressive what receivers can do. I mean, I know of receivers that can monitor, minus 164 down dBm, and what the supposed to be the absolute noise floor is minus 174.
Yeah, pretty amazing.
It's very amazing what the receivers can do especially with the environmental noise that's out there.
So let's go back a little bit. You said that, of course, amateur radio was the reason that you kind of chose or made the career choices that you made also for education. Where did you go to school?
I went to DeVry Institute of Technology, which is now known as DeVry University, because they've expanded in other areas. It was one of those technical trade schools that focused heavily on electronics, math, and physics. And so I thought that I would learn more by focusing and actually having labs to where I was working in a lab for a couple hours a day, doing electronic troubleshooting and design and stuff. So I felt that was more hands-on, and that went along much of what I did with amateur radio.
And when you left DeVry, where did you go?
Then I went back on over to San Diego. Then I took evening classes in computer science at UCSD. I did that because I could see the computers were the writing on the wall. Because when I was over in Arizona going to school, I had built a lot of the do-it-yourself computers, the MSI 8080. In 1977, I went to the first West Coast Computer Fair up in Moscone Center near San Francisco, and I met Steve Jobs and Steve Wozniak, and sitting on this fold-up school table in front of me was an Apple I computer and a prototype Apple II computer, of which Steve Wozniak tried to sell me an Apple I computer, and he said, hey, these are hand-built, this is the way to go. And I was so impressed because all the stuff that I was doing in college on Fortran was on these huge IBM 360 punch card type things, and I had big boxes of Fortran punch cards. And I go, you're going to be putting these in people's homes? And he showed me his business plan, how he says, I'm going to put it in every classroom. And these kids at the end of the year are going to go to mom and dad and say, I want one of these Apple computers for a Christmas present. That's what Steve Jobs told me.
Amazing. And that's exactly what happened.
He followed through with his business plan. And I went on and designed some Apple circuit boards. And how I got started then, after I got out of school, I did a 16K RAM card so that people could run UCSD Pascal and CPM and some other languages because they just didn't have enough memory in the Apple II computer. And had fun building those and selling a whole lot of those cards.
Now, it's my understanding that you went to work for Southern Pacific Railroad. What happened there?
Well, I did that because I had a neighbor who actually was doing that, and I traveled all over the country. He said, Ray, if you want to pay off your school debt, your college debts, come work for the railroad. And I was like, huh? And he goes, yeah, you're out on the road all the time checking all the railroad track throughout the country. And so I said, that's different. And he goes, yeah, there's this cool rail car that you'll ride on, and it uses Magnaflex and sonic testing of railroad track. And I'm going, how does that all work? And he goes, well, we magnetize the railroad track and we look for fractures in it. And we use sonic testing where we'll take a crystal and we'll send a sonic, like a sonar beam into the railroad head through the web to the base and reflect back up and look for any fractures in the railroad track. And I said, now that is pretty neat. So I designed an item for Southern Pacific Railroad that helped find faults in their railroad track so they could drive down the track much faster, and it would show where there was breakages in the track.
Oh, that's pretty cool. I mean, who thinks that railroad tracks would break? But in fact, that they do.
Derailments happen every day.
Yeah.
They do.
Yeah, especially, I guess, in places where it's extremely cold. It seems to me that railroad rails could become brittle in the cold.
They do, and the railroad track is just like a big coat hanger. You move it back and forth enough, it breaks. And a lot of the trains these days that have got cars on them and things are very heavy, and going, residents on a lot of the track it does break. And when it breaks, it's usually a $5 to $10 million worth of damage of some, hardware and equipment going onto the ground.
Magnaflex and sonic testing, then, of railroad tracks is a must. Is it still being done this way?
It sure is. There's a company, Sperry, who checks the track. Every 30 days, every piece of track that Amtrak is on is tested for safety. A railroad is still the number one way of moving freight across the country. None cheaper. A gallon of diesel fuel per ton of hardware can go quite a distance.
And now this message from Ikon America, makers of the finest amateur radio transceivers for every level of amateur radio operator. Calling all hams. Ikon knows that amateur radio is all about community and wants to give back to the amateur radio community that has been loyal to it for over 50 years. To this end, Ikon has launched 2 initiatives. The first, Ikon has launched a promotion exclusively to ham radio clubs. By registering your ham radio club, your club could win an Ikon radio, Ikon swag, a live presentation on Skype, or a live in-person presentation by an Ikon rep at your ham radio club meeting. Secondly, according to the ARRL website, there are over 195 conventions and ham fests scheduled in the United States in 2019. Ikon knows that hamfests play a big role to bring hams together to learn from their peers and radio industry leaders. Ikon has launched a promotion exclusively for hamfests. Register your hamfest today, and your hamfest could win an Ikon swag, a forum presentation, or an Ikon booth set up at your hamfest. For more information and to register your club or hamfest, click on the Ikon image in this week's show notes page. You can also search on Twitter and the Internet using hashtag Ikon Everywhere, one word, that's hashtag Ikon Everywhere, or go to ikonamerica.com/amateur to register your club or hamfest. My thanks to Ikon America for being such a wonderful sponsor of the QSO Today podcast. Please be sure to tell your dealer on your next Ikon purchase that you heard it here on QSO Today. And now back to our QSO Today. You mentioned to me as we started that you're an expert in electromagnetic compatibility. What is electromagnetic compatibility, and how did this play out for you?
Well, after I left the railroad, and which I was able to pay off my school debt very quickly, by the way, that was a very nice venture. I went to work for a little startup, well, not a startup company, but one of those think tanks in San Diego. And I was able to go to Europe to learn how to do hardening of the NATO stations over there, the satellite terminal stations that were part of the NATO community. And it was for hardening for EMP, electromagnetic pulse, which was considered to be a big threat in the 70s. And so I went over there, and my ham radio knowledge, once again, I set up a swept CW transmitter that used a computer to step control the frequency, and it would emit a signal, and we would have monitoring probes inside the facility clamped on to telephone lines and transmission lines and power lines and lightning protection systems. And we would monitor how much of our swept energy outside the facility got coupled into the facility, and then what we needed to do to filter and transient protection and stuff against the EMP threat. And I said, this is very neat, because I was able to use my amateur radio knowledge doing transmitters, and then my stuff with computers and working with the digital PDP-11 type stuff way back when. And and saying, wow, I can step through frequencies of a constant transmitted signal, a CW signal, and then monitor the energy coupled into a facility and then harden for that and shield and do all those things. And so I said, this is a neat specialty to be in. And so then I got into electromagnetic compatibility and interference type stuff, going, what I learned from doing EMP, I was able to go on over and say, oh, how can I make radios and transmitters better? And even today, when I go to trade shows, our amateur radio conventions, Dayton and all these, I will take a look at a radio and I will look at all the big brands that are out there. The Ikon, Kenwood, Yaesu, Flex Radio, Elecraft that Wayne is with. I will look at all them and I'll say, I kind of chuckle inside going, these guys can still make their equipment a little bit better to get rid of some of the birdies they might hear and some of the upsets in their receivers, because I still see a lot of hardware still being made incorrectly.
Do you have a piece of test equipment that you carry with you when you're looking at these devices?
Well, handheld spectrum analyzer works really well, but you can usually see some very obvious issues for your people listening out there. If you just take a look at your radio for a moment and take a look at the back of it, you'll see that there's connectors on the back of your radio which aren't tied to chassis. A lot of plastic connectors are used these days, which go right on inside your radio, and they do not terminate at the periphery of the chassis. When we design stuff for the military, you have to think of it, you start off with a box that's a Faraday cage, and that it's a solid box, and as soon as you poke a hole in it to put a display on it, put a fan on it, put a knob on it for controlling stuff, volume and squelch and RF sensitivity, whatever it might be. Anytime you put a hole in a box, you degrade the integrity of that shield enclosure. And so I see a lot of ham radio stuff, and especially commercial stuff too, to where they don't maintain the integrity of that shield, because an empty aluminum enclosure will give you 120 dB of isolation. But as soon as you start poking holes into it, to route cables through it through the back, you've essentially now just have a box that's not providing you a whole lot of shielding, because whatever cable you connect to that box is going to act as an antenna and bring that noise that it sees on the outside world right on inside your box, and vice versa.
Have you created a WA6NVL list of electromagnetic compatible amateur radio transceivers?
No, I have not.
Seems to me there's an opportunity there.
Yeah. Well, it's just that I don't want to pick on any of these manufacturers, but I do go to the trade shows, the aerospace trade shows, and I do show those guys. I'll take a look at their hardware and I'll say, you guys should be doing this and that sort of thing.
Is there anything that amateurs can do with the new stuff in order to improve its performance, even tightening up the connectors on the back? Well,
yeah, the connectors, that is, if it's a metal connector, a lot of them were like a DB25 that a lot of the newer ones are using. The DB25 is connected to the circuit board, and it's not tied to the chassis. When they built a lot of these radios, they really need to have the connectors, all of them, even the DIN connectors, they need to be just like your PL259 for your RF connection or a Type N connector on the back of your chassis. They need to be bonded really well. And the term bonding I'm using is where you take two fang surfaces, and that's the military term there. These are two metal surfaces that are meant to be tied together for a very low impedance connection. If you can take a milliohm meter, which is a whole lot more sensitive than your standard ohm meter type device, and you measure all your connectors on the back of your radio, if they're not 2.5 milliohms or less, you will have leakage going in and out of your box. And so there are some recipes. And I know there's another thing that, a lot of the basic principles that we all learned in school or in amateur radio, such as grounding. I need to get the word out there, folks. The only ground there is the earth we walk upon. Because people tend to use the term grounding very loosely. Really, in a lot of the Kirchhoff's laws and some of the things that we learned in college was when you've got energy leaving a power supply, if it's got to have a return coming back. And so I call them return currents. And so I changed things at Hughes and Raytheon. A lot of the people didn't like what I did because I started using IEEE standards by using different than the fork and the rake and, the different symbols that we had all grown up using for grounding, because now you want to isolate your digital world from your analog world, because you don't want digital noise, which is, shifting from 0 to 5 volts or whatever it might be, getting into your very sensitive receivers, which are looking for microvolts of energy. So you definitely need to isolate your digital and analog, and even laying out the circuit boards and everything. But so I had all the symbols changed so that we would know what is digital ground and what was analog ground. And it made a big difference on where we would install our filters for isolating receiver channels and transmitter channels and our stuff.
Hey, this is Eric for just a short break. One of my favorite ham radio podcasts is the Ham Radio Workbench podcast, hosted by George, KJ6VU, my guest in episode 232, and Jeremy, KF7IJZ. George and Jeremy take a bi-weekly deep dive into their favorite ham radio projects and technologies that fascinate them. If you want to be a ham radio builder or just be inspired, click on the link in this week's show notes page. For amateur radio operators, well, I'm probably one of those. I'm on a second floor. The ham shack is on a second floor. So running a 6-gauge cable down to a ground rod doesn't seem very practical for me. One, because the run is going to be long, and so potentially that ground could be resonant. What does a guy like me or someone who's in an apartment building or something, what do they do?
Well, that is difficult. The best thing that I can recommend is that when we typically go out and do a field day, amateur radio type thing, we typically don't run ground rods into the ground. And the best thing we can usually, that I can say by helping reducing noise and in your system, is to have all your devices at the same potential. So if you have to run a strap or a ground strap, a bonding strap, it should be between your radio components. Your antenna itself these days, if you can ground the antenna at the antenna, most of them have a DC ground in them, or a balun of some sort where they are referencing the case. That you'd want to take that directly to earth for lightning protection and static buildup. I mean, P static is a big deal. With just the wind blowing across your antenna can build up a static charge, and that snap, crackle, pop will be heard in your receiver.
Yeah, you can even draw an arc, I think, off of in a nice dry desert climate with the wind blowing across your antenna. You can draw an arc off the center conductor of your feed line. I have.
And even in space, some of the early satellites found out that solar wind across the solar panels would build up a charge on the solar panel, avalanche, and break down and do a high voltage pulse on your system and kill your satellite.
Who would have known?
Oh, I know. Who would have known? That ESD protection is needed everywhere.
Is it fair to say that you've been involved in the quote-unquote land mobile repeater remote-based side of ham radio for most of your ham radio career? And how did that start for you?
Well, that started because of CC&Rs. When I moved up to Los Angeles, I moved into an apartment, and even right now I'm in a condominium up here, and the CC&Rs, they don't want you putting up big antennas. So I had to think outside the box, saying, okay, well, if I can't have it here, where can I have my radio system to be able to talk to other people? And so that's when I found out about, the repeaters that we used, the VHF repeaters in the early 70s. They were all up on mountaintops. Then we found out we could put a link up to those mountaintops and have that as a remote base. And we found out we could put in radios that we could control the frequencies on those. And now it's very simple to have remote bases. A lot of people throughout the world, the DX contesters, are using software-defined radios as their remote receivers. And they're all over the United States and all over the world, so you can listen to your own signal from another remote receiver somewhere else. So remote base is fun because you can take a little handheld radio that's not offensive to anybody, and then talk to a mountaintop that's going to rebroadcast you, or over the internet, using your computer to talk to a remote transceiver. And that's being done quite a bit these days.
And that's what you're doing with the base station down in San Diego.
That is correct.
Uh-huh.
I can use a smartphone, a smart pad type device, a computer. All those I can get into my transceiver in San Diego and be frequency agile and power agile. I can turn the power down on it, receive only, turn it into a remote whisper receiver station and broadcast those receiving signals out onto the internet for other people to take advantage of. So our transceivers these days are multi-purpose, multi-use. It's not just for me anymore. Now I can share it with other people.
Now, are you involved in any organizations down there that maintain these remote systems and repeater systems?
One of the biggest groups that I'm involved with is the Poppa radio system. That's PAPA system.com or PAPASYS.com. That group is very neat in that they've got about 40-something repeaters that are either analog, Ikon D-Star, Motorola DMR type stuff, Moto Turbo. So they are on the forefront of very large networks of where when they have their weekly nets, people check in from all over the world, from Australia, New Zealand, England, all over. And so it's a very it's a bunch of professionals that have been in the TV broadcast business here in Los Angeles, the NBC, ABC, CBS type affiliates. And they're a very proactive group and staying very current in technologies, all the different technologies out there.
Well, you seem to be an early adopter of digital mobile radio, I think beginning with D-Star. How did that start?
It started because I saw that ICOM had put out a system saying we're going to go digital radio. And right there was the very first time that I heard that amateurs were going to be using digital radio. And that I think was like in 2007. And so I took the ICOM class that they had for everyone to be a system manager to be able to run their software. It just had some issues in the beginning because the guys up in Washington at ICOM was having little issues decoding the manuals that were coming over from Japan. So it was hard for us to get our software set up. I said, wow, this is a very neat system. A person can set up a repeater in Los Angeles and talk to another repeater in New York or where your physical location is right now using the internet. And because the internet was pretty established. And I said, well, this is neat. We can now take amateur radio over the internet. But I was having some issues in keeping D-Star stable. And that's why I was looking at other avenues. And I saw Motorola. And I saw the Motorola Moto Turbo device. And I said, now this is a neat repeater because it's got all the smarts of it built into the repeater. Whereas D-Star, I had to have an external computer. And that external computer was the server that my repeater was connected to, and it would push the data out onto the internet. And the Motorola one had an RJ45 right on the back apron. And I said, now this is really interesting. So in 2009, Motorola enabled that connector in their version like 1.1 software firmware build on their repeaters. And I and a friend in Iowa and another friend up in Washington, I became the master repeater, and I called them on the phone. I said, here's my IP address here at my house, and you guys connect to me. And we all got connected up in 2009, and I think it was the first time. I mean, even Motorola hadn't done this yet. And because it was like they released the software, and here I had amateur radio connecting interstate repeaters, and the audio is as good as what you're hearing right now, us doing, this conversation this many miles away.
I was talking to one of my earliest mentors this week, who still is working for Orange County Communications, and he says that the state of California seems to be going P25 on its public safety, and maybe that's going to become a universal standard. Do you see P25 becoming a popular amateur radio digital mode?
No, I do not. In fact, when I've gone to the different club meetings, we've polled the people to find out what they thought about P25. P25 is a commercial world item by the APCO for the public safety. And one of the things with P25, like when we used to buy computers or when we still buy computers, you have to pay a software license. And the P25 software license was very cost prohibitive for the amateur community. I mean, just the license alone is $200 to $250 per radio. And a lot of our amateurs, that are getting into digital, they want to be able to buy a radio that does DMR or that does D-Star for the $150 type area to be able to get involved into amateur radio if they're going to go digital. And so it's very cost prohibitive, and getting a hold of those radios, the P25 radios, yes, there is a surplus market of them, but not a whole lot of people are able to work on those. You have to take them back to a Motorola facility or one of the other P25 facilities, Bendix King, and have them serviced, and it's usually kind of cost prohibitive for the amateur.
And now this message from QRP Labs. QRP Labs has shipped thousands of QCX QRP transceivers kits to date. The odds of working another QCX user gets better every day. If you're looking for a satisfying kit experience where you end up with an amazing performing QRP transceiver for under $50, let me say that again, for under $50, then you owe it to yourself to go to QRP Labs. We have many home brewers who listen to the QSO Today podcast. For you, QRP Labs also has parts, filters, enclosures, and other handy devices to make your home brewing experience even better. You can use these parts to either enhance your QRP Labs kits or to beef up your own homebrew designs. Be sure to browse Hand's entire website. Use the link on this week's show notes page or the one in the sponsored section of the QSO Today website to get to QRP Labs to buy your QCX or any of the other fine QRP Labs kits or parts. QRP Labs is my go-to ham radio kit company. It should be yours too. QRP Labs. And now back to our QSO Today. But Motorola, I think, is also famous for licensing, perhaps maybe just service software, but maybe radios as well. Do you still see that Moto Turbo is going to continue to be popular, or are we confusing that, and that's also DMR now?
Well, yeah, DMR is the generic term, digital mobile radio, that all the companies out there have adopted. The Moto Turbo, the trademark for Motorola, I foresee that amateur radio people are still going to continue to use that because of so many people writing now code, the digital multi-mode access points that people are putting up all over the place. I mean, you can use a little handheld radio in your home or your hotel room and talk to a little hotspot in those locations and talk anywhere in the world using a little, 100 milliwatt radio in your room. And DMR, the audio sounds very good. It's a little better codec than D-Star is. And now the next generation of Yaesu System Fusion is the audio sounds even better. And now amateurs like it because they're able to incorporate APRS, that amateur packet reporting system, into their radio. So now they can be driving around and somebody can see their coordinates on Google Maps exactly where they are. And being that amateur radio is like, it's the first volunteer, if you want to call it there, first guys on the scene. If you look at down in Costa Rica and stuff, some of the areas, I mean, amateur radio was on the air way before the big boys showed up. I mean, we were giving health and welfare status and, water and power and what the situations were from people's cars. And so amateur guys are very agile, adapting, thinking on their feet, and that's what makes our community so special. And that's why I think that a lot of the governments are realizing that, and they're trying to make sure that our frequencies are protected because we provide a service to people that the commercial world doesn't have. Paid people don't have.
How do you think that digital mobile radio will play out? In other words, do you see an amateur radio adaptation of DMR, for example, that makes it friendlier? I'm using DMR, and it has its pluses and its minuses. One of its minuses is I could be talking in a talk group on one of the two time slots on the DMR repeater, and then somebody else keys up in that time slot, and all of a sudden my conversation goes away. Do you think that we'll have the ability at some point to be able to modify the way this works so that it's friendlier for us?
DMR is built on TDMA, time domain division multiplexing type. And TDMA is, cell phone technology that's been around for a long time. The repeaters that we currently use for DMR with 2 time slots can easily support many more time slots. They just have not enabled it, the commercial world. Remember, we're using DMR from the commercial world because they don't want to take away what's called trunking systems, to where you have 6 or 8 discrete repeaters that are being told by a control channel frequency where your radio is going to go and talk on. We could actually time slice up one of our DMR radios and easily probably do 8 to 10 time slots on one repeater frequency. So you could easily support many more users on many more time slots on your repeater. That just has not been enabled yet.
So, in other words, it would be possible for our radios, if we choose a time slot, either to reserve that time slot because we're using it, and so that time slot won't go away, though there's just other time slots, and then the radios just kind of find an unused time slot and establish a conversation on a talk group. That's kind of what you're saying.
That's much like how trunking radio works. You could be talking on one frequency one moment, and then the control channel has you talking on a different channel the next moment on your next key up. We could, once you have a talk group that is being controlled by a server, it could move you around on different time slots and control your radio and say, okay, I want you on time slot 4 now. Or like you said, reserve a time slot and say, okay, only this talk group is going to be on this, and then you won't get knocked off. But there's a good chance that you're not going to have 8 or 10 users using that one repeater at the same time.
Right. Right now the problem is just having one other user using that time slot, especially if, in the case here in Israel, we reserve one time slot for the nationwide calling channel, and then we reserve the other time slot for everything else. I'm looking forward to that. I'm looking forward to that advancement. My research revealed that you're a user of Dog Park Software's Mac Doppler Pro satellite tracking software, which leads me to believe that you have an interest in amateur radio satellites. Is that true, and how did that get started for you?
Well, ham satellites, that is a whole lot of fun. It's fun because it takes amateur radio to the next plateau you just can't pick up a microphone and start talking. You have to look at Keplerian orbit information of where the satellites are moving, because the amateur satellites are not geostationary. They are always on the move. And they're what is known as LEO satellites, the low orbiting satellites that are about 400 to 500 miles up. And they're moving around, and they pass over, it takes them about 90 minutes to go around the Earth. And as they're going around the Earth over the poles, the Earth is turning underneath it. And so it makes different passes all day long. And amateur satellite has been fun because now I have to use the technology of, a computer so I can track when the satellites are going to be overhead, when they're coming. And the Dog Park software that Don has written up there in Canada, which I met him many years ago, he writes some really cool software along with some of the stuff that's for PC stuff out there. I just like the Mac stuff because I had been involved with Apple from 1977 on type, that I can then look at where the satellites are, all the amateur satellites, what the status of them, what mode they're in, if they're running FM or sideband, because we have linear transponders. Amateur satellite is really neat because it takes a little bit of talent to do it. You have to know when the satellite is coming over the horizon. You know how much time you've got to get in a word edgewise. Your conversations are kept very short, but you'd be amazed on where you can talk to people. And I don't have to rely on the infrastructure. I mean, the power could be down at where I live, and that satellite is solar powered. And so I'm going through a repeater in the sky, that I can talk all over the United States, and with the store and forward capabilities to be able to talk anywhere in the world. So amateur satellites, I've been involved with them since the early 80s. When I moved up to Los Angeles here and was in the apartment, I said, well, along with remote bases, I can have a little handheld radio, a little base station, and talk through satellites. So I found that was a whole lot of fun.
What's your satellite rig of choice then?
For right now, I use an old Kenwood TS790. The reason why I like some of the older radios is they were full duplex. I could hear my own signal coming back down through the satellite. So I could easily compensate for a Doppler shift. As that satellite is moving, you have that Doppler that's changing. And I have to always adjust my receiver. I leave my transmitter fixed, but I adjust my receiver as the satellite is coming and going, so I can hear the guys much better.
And what's your antenna of choice in your apartment there?
Well, right now I just have I use the K2 egg beaters. I just have them out on the balcony because I don't have to point those. But when I want to make a really good contact, I'll use like a handheld beam that's made by Arrow, the Arrow antenna, which has got both VHF and UHF on one handheld Yagi type antenna.
I noticed that you're active on APRS, and you mentioned earlier, about the automatic packet reporting system. When you put in your call sign into the APRS site, it shows that you have devices all over Southern California. Does that mean you have cars parked all over Southern California? What does that mean, and how are you using APRS, and what purpose does it solve for you?
Well, the purpose was to help my wife know where I was at. Now we can do that on Find Your Friends these days on smartphones, sort of thing. It was also, as I was traveling around, I could then see where different receivers were located that were taking my signals as I travel on vacation, and I'll go fishing or, go out camping and stuff. As I go through the hills, I like to know where the propagation from where my vehicles are at, and I will travel and then look at all the remote sites and all the, other receivers that heard me. And so it kind of gives me an idea where other amateur stations are at. So in case of emergencies here in Southern California, I know that I can go to a location and that other amateurs, even though I'm out in the middle of nowhere where there's no cell phone coverage at all, I know that there's other amateur digipeater type devices that will hear me and that I can get a message out. And amateurs, wow, they're the underdog. People don't really understand the assets that we can provide to the world.
Okay, but you have multiple receivers that are spread around. How are you using those? Are they on lampposts? Are they actually sitting in vehicles someplace, or is it that was like the last place they were before they were switched off?
That is correct. Those were typically the last places that I was using it on that trip, so that I just wasn't beaconing all the time. I would go on a trip and I would have different vehicles, either the cars or motorcycle, or I would be with friends, or I'd take my handheld radio with me and travel with friends and stuff. And so each radio has a different identifier in it because they're programmed into the radio. So that's why there's the different dash numbers.
I see. So what I see on the map is the last place that transceiver had been working before it was shut off.
That is correct.
Oh, interesting. Okay. What do you think the biggest challenge is to amateur radio now?
Well, the biggest challenges I see are as amateurs are finding more restrictions imposed upon them. The places where people live right now, they don't want to see an amateur antenna up in somebody's backyard. Heaven forbid. Everyone is controlling everybody these days, and they just, if they don't like that piece of metal in your backyard, they say it's got to go. And so there's antenna restrictions that are, where people used to operate just fine for many, many years. All of a sudden, someone's knocking on the door and saying, you got to take that eyesore down because your neighbor doesn't like it. And so now amateurs are getting more creative by making antennas that aren't as offensive, by making some of these spider web antennas and stuff. And you can say, yeah, that's my clothesline in the backyard now. You going to take down my clothesline, sort of thing. But I understand they were concerned that these large antennas were going to fall over on an earthquake or something. But the communications that we provide, a lot of people are still pretty ignorant in what amateur radio is all about, because they say, I have my cell phone. Why do I need to have you in my neighborhood? And amateurs try their darndest to make sure they don't interfere with anything at all. And many systems, now are cable TV or satellite TV. We have much less interference than what we used to. And so, but just a lot of people you even see it in the solar and the green world. People don't want to have somebody putting up a windmill in their backyard generating power because they don't like to see this prop turning around and somebody taking advantage of wind. So there's just a lot of people that need to understand that our technology is what saves lives and that someday could save their neighbor's life.
Well, I think you've just had a recent major fire in your neighborhood. What role did amateur radio operators play there?
Well, amateur radio, our repeaters kept working when commercial repeaters would go down. Some of the hilltops, some of the installations that were commercial and owned by the government and the police departments and fire departments went up in flames. And then they were just talking, car to car with their radios. Amateurs could still provide at posts. We would station up on posts and be able to give people some heads up on what was going on at the fringes of the fires, and also be able to let some of the people that were looking at which direction the fire were going. We would, like the folks have down in Florida, tornado scouts and stuff, looking where the tornadoes and hurricanes are and stuff like that. We had people what direction the smoke and the fire was going, and to be able to give people heads up that way. And amateurs were there, Johnny on the spot. They were mobile and they could move and be great spotters.
Yeah, the fire we're talking about, I think, is the Malibu Fire, right? That was November?
That is correct. Well, we've had many fires in Southern California here and in California itself. The largest fire that California's ever had was just a couple of months ago, like you're talking about.
Now, the Poppa System has its repeaters on one of the. It has its repeaters on many sites in Southern California, but one of those sites was Saddle Peak, which is right above Malibu. Did Saddle Peak survive?
Yes, it did. It was in one of those areas to where they had maintained the brush and shrubs around that facility. So it wasn't knee-high and shrub brush and trees and stuff like that. It was very clear location.
So as a result, the Poppa System was able to provide communications to the entire area where the fire was then.
That is correct. And also the Poppa System does not rely on landlines. Many times our interconnectivity between sites is done on microwave. So we're using 5.8 gig ubiquity microwave to intertie the radio sites together now. And so when the telephone lines go down, Poppa radio system keeps working.
How would you attract young people to ham radio?
Exactly what we are doing with the two schools in San Diego. And it's exactly the same business model that Steve Jobs had. I would get companies like Ikon, Yaesu, Kenwood. Instead of marketing and magazines, I would say, put radio stations in all the school science centers. Go to these schools and say, how would you like to get technology? I mean, when I was at Raytheon, we actually sponsored robotics, getting kids into designing and building hardware that were radio controlled, RF controlled robots. So they had to learn RF, they had to learn, servo motors, power systems, control systems, computer systems, put it all into a robot, and then they would put them out onto a floor with a challenge to go do something. And we had it at Raytheon, it was called Math Moves You. And it was all about, we were giving grants to all the local junior highs and high schools, giving them money to promote kids to get it back into science.
That seems like a kind of a normal, natural thing to do. I know that ICOM is very generous to the Boy Scouts of America, for example, and so all of their big programs, their Yoda program, their big gatherings include ICOM gear. I think that's probably that's probably a good lead for a lot of amateur radio companies in terms of if they want to build the audience, then they need to put the equipment where the kids are.
A simple little coupon once you pass your amateur radio, get your license, somebody ought to just hand you a coupon that's good for 25% off the handheld at that manufacturer. That Ikon could easily give a person a coupon that says, when you pass your ham license and you just finished there, you have a choice of, Kenwood, Yaesu, Ikon. Here's a coupon that you can go over to HRO, which they would love to have the business, and go in there and get you a new radio and get you started. But nobody's discounting. Nobody is giving that first jump start to help somebody out. And I know there's a ton of hams that have got a lot of spare radios laying around.
By the way, I think that in itself is could be a whole source of equipment. I mean, we all do. I do. If you scratch any of us, we've got radios sitting on the floor or up in the attic that could be retasked for a new ham.
And the thing is that now, that when we went and bought those radios, we put a lot of hard-earned money into getting those radios and stuff and took care of them and things. And we know that if you just hand it to a kid, they may play for it a couple of days and then throw it away or drop it or smash it. It's kind of like we go, wait a minute, this is something you ought to really cherish. But we know a lot of the younger kids these days, it's like a disposable society. And so I'd rather see some stations set up in some schools, but even the schools don't have the talent. Like I said, my English teacher was the guy that got Wayne and I into ham radio, was the English teacher. And he spent the time going to the school principal and saying, I would like a room that I can go and put some equipment into so that these kids can learn about communications. He didn't just say ham radio. He said communications. He goes, I want to get some scientists and some engineers started out of this school. And the way they're going to learn that is by hands-on with, electronic components and stuff.
Well, maybe then what amateur radio clubs should do is maybe amateur radio clubs should adopt a school as a place to meet, because amateur radio clubs are always looking for places to meet, right? But also as a place to set up a station, so that if you had an amateur radio club supporting a school station, then you'd have enough amateurs that you could actually man the station semi-regular basis. And as you say, the majority of us are 60 and over, so if we're retired, we have lots of time. And maybe that's a way to create this hub in a school that attracts kids to at least what's going on in there and see what's happening.
Well, that's where we went over. Carmel Mountain High School in San Diego is where we were doing the balloon flights with APRS. And then we went, the kid who graduated from there, his name is Owen. I showed him how to get grants from the ARRL. He's now received 2 grants. One was a Dayton grant for $1,500, and one was ARRL college grant. NOWEN is his call sign. He's now a student at UCSD, and that's how we got the college to start a ham radio club. Was we put Owen over there, and he got a bunch of his fellow students together and said, hey, let's get an amateur radio club started at a university here in San Diego, which they hadn't had for many, many, many years. So then we found some people to sponsor them. I found a couple of guys that gave a whole lot of money to get those schools with amateur radio now. And one of the donations that we made to the high school was for $28,000.
Well, you could do a pretty good rig with $28,000.
Oh, we got soldering stations, we got oscilloscopes, we got handheld meters, we got libraries, we got digital art. We got a lot of stuff for those.
So you created an electronics department.
That's what we did. We went to the school principal and said, you need this as one of your curriculums. And now that school has turned out like 60 hams.
Wow.
Yeah, in the last 2 years.
Well, amazing.
And so it's kind of like what Steve Jobs did. You have to plant the seed, and then you have to water the seed to get that plant to grow. You can't just drop off a computer and say, good luck, guys. No, he stayed interactive with all these schools throughout the early 80s. And then he got the Macintosh, and then kids said, wow, this is really cool. I can draw. Yeah.
Right. Created a whole generation of computer nerds that transformed the Silicon Valley. What's your favorite piece of test equipment?
Well, I have two. An oscilloscope, spectrum analyzer, and a regular handheld voltmeter. Depends on what I'm looking at.
Do you have a service monitor?
No, I do not have a service monitor because the spectrum analyzer I use has a built-in tracking generator and signal generator.
So there you go. You got almost all the pieces.
That is correct. The service monitors of yesterday, so to speak, some of the bigger Cushmans and Motorola's and Singer type devices, they essentially were a spectrum analyzer and an oscilloscope and a voltmeter all built into one. But the equipment that's out there today that you can obtain for amateur radio stuff, I mean, you can buy a very nice spectrum analyzer now for $1,200 that covers up to 1.5 gig.
Right, and you won't get a hernia carrying it around.
No, it's very small, lightweight. Yeah.
How about that? What excites you the most about what's happening in amateur radio now?
I would probably say the software-defined radio and digital radio. Because I had done that for so many years with the military, I am so impressed with amateurs are doing for a few dollars compared to what we had spent, doing similar type stuff like that for the military. Amateurs are really thinking on how to make very small stations and produce very high performance. The stuff I'm seeing coming out now from Ikon, Yaesu, Kenwood, and some of these, the radio is getting smaller and smaller and smaller, but the performance is just incredible, the radios that are out there now.
What advice would you give to new or returning hams to the hobby?
It's going to get very exciting. Amateur radio with digital, just like we're able to do with computers, people are going to see that they can send live video streams on amateur. It'll be a little more enjoyable, some of the new technologies that amateur radio is going to be providing. I know guys are being able to take a picture right now and send it over the air to somebody else saying, I'm looking at this traffic accident. You don't want to come this way. This is a picture of what the accident looks like. And they just took a quick snapshot. It's gone over the air. And a whole lot of people are looking at it in real time, long before the news media even sees it. But I think that the people that are out there are going to really start enjoying the new technologies. It's not just talking on a radio, because like people said, I can do that with cellular telephone, but you can go anywhere and not be in fear of breaking your leg and nobody not coming out to help you, or you're not going to have to saw off your hand like that one gentleman did. I mean, there's so many things out there now that amateur radio guys have that are going to be game changers.
Right, we really have a versatile toolkit these days, much more than we did 45 years ago.
Oh, that's so true. And it's the efficiency of the stuff that amateurs have are so much better than the commercial or military world right now as far as performance. It's very impressive.
Ray, it's been really cool to catch up. As I said at the very beginning, we met each other 45 years ago, and it was so nice to see you once again at Pacificon conference in California, and I hope to do it again. And I hope that if you're ever in this part of the world, you'll look me up, and we'll have an eyeball QSO and maybe shawarma, something like that.
Well, it was great speaking with you, Eric. I know it's late for you there. It's nice and cold and rainy here in Los Angeles today, and I hope you have a great year, sir, with all your fantastic podcasts.
Yeah, thank you so much. 73, Ray.
73, Eric.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Ray. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in WA6NVL in the search box at the top of the page. My thanks to both Comm America and QRP Labs for their support of the QSO Today podcast. Please show your support of these fine sponsors by clicking on their links in the show notes pages, or when you make your purchases, that you say that you heard it here on QSO Today. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the other episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes page. I am grateful for any way that you show appreciation and support. It makes a big difference. QSO Today is now available on iHeartRadio, Spotify, Libsyn, and TuneIn, as well as the iTunes Store. If you own an Amazon Echo, you can say, Alicia, play the QSO Today podcast from TuneIn. I still use Stitcher to listen to podcasts on my smartphone. The links to all of these services are on the show notes pages on the right side. Until next time, this is Eric for Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.